perform and complete a full two-mean hypothesis test with dependent samples. Critical value approach. First, let's look at our problem. Now, this might be overwhelming because there's a lot of words and this is a math course, but don't be alarmed. Get yourself a piece of paper and write down the important information as you read through the questions. Okay, let's jump in. A pharmaceutical company claims its new medication will make a difference in the number of monthly headaches for those who suffer from migraines and conducts a study of 8 regular migraine sufferers. The number of headaches that each patient had in a particular month before taking the medication was recorded. Then, during the next month, the same 8 patients take the new medication, the number of headaches is recorded. The results of the medication study are shown in the table at the right. Assume that both populations are normally distributed. Is there sufficient evidence at alpha equals 0.01 to show that the number of monthly headaches has changed with the use of the new medication? Note, variable D, which is the difference, is the number of headaches before the medication minus the number of headaches after the medication. The order matters when you're finding the difference, and then you're going to find the mean of the difference, the standard deviation of the difference. The order definitely matters. So now let's work through the test procedure and interpret the results of the hypothesis test. Before we do that, let's review those steps. First, we're going to identify the null and alternative hypothesis. Then we'll decide on the significance level. We'll compute the test statistic, and we'll find the critical value. From that, we will be able to interpret the results of the hypothesis test. Let's jump in. The first part, identifying the null and alternative hypothesis. Recall that the null hypothesis is always equality. It's got the equal sign, while the alternative hypothesis shows the inequality, which could be less than, greater than, or not equal to. In this particular example, we want to see if there is a difference in the number of headaches. Therefore, we're going to use that not equal to, because we're just showing a difference. Therefore, our null hypothesis will be mu sub d equals 0. So the mean of the difference would be 0. And then the alternative hypothesis would be mu sub d is not equal to 0. As we know, because we are not equal to in our alternative hypothesis, this will be a two-tailed test. 2, let's decide on the significance level. Well, we're given the significance level in the initial question, so we know that alpha is 0.01. We're going to need that to find our critical value. Next, the test statistic. It is always important to recognize what formula is needed before you start and just jump right in. In this particular case, using a two means with dependent samples, we're going to use the t-distribution test statistic. We're going to need the average of the differences, the standard deviation of the differences, and our sample size. So from the table, you're going to find that information. You calculate the difference between each before and after, and calculate from there. So we find the average differences to be 1.25, the standard deviation of the differences to be 1.98. That's rounded to 2 decimal places, and our sample size is 8. Once we have our given information, now we can substitute into that formula, remembering that mu sub d is our claim, so that value is going to be 0. When I substitute in the values in the correct positions, you plug this into your calculator. Make sure you're using parentheses to follow the order of operations. When you do that, you end up with a test statistic of 1.79. Remember, in the critical value method, we're going to compare that test statistic to our critical value, and that's how we can make our decision. So moving on to step 4, we need to find that critical value. Because we know it's a two-tailed test, we're going to need a critical value on each side. One's going to be positive, one's going to be negative. Since our level of significance is 0.01, the total area of the tails would be 0.01. In each tail, we're going to have to divide that by 2. So the area in each tail is going to be 0.005. We use that 0.005 to find our critical value. We're going to use the t-table. Our degree of freedom is 7 because we have a sample size of 8. Looking at that, we get a critical value of 3.499. And because it's two-tailed, we're also going to have a negative 3.499. Now recall, if we're dealing with the critical value method, if the test statistic is less than negative 3.499 or greater than the positive 3.499, then we will reject the null hypothesis because the test statistic will fall in the rejection region. In our case, the test statistic is 1.79, which actually falls between the two. Therefore, we do not reject the null hypothesis. Interpreting that, at the 1% significance level, the data do not provide strong evidence to show that the new medication changes the number of monthly headaches for those that suffer from migraines.